All right, the second video in this unit, which is unit 3-1, is on sets and dictionaries. And sets and dictionaries are a different kind of data structure, especially dictionaries. They're completely unique from anything we've talked about so far, but they're called dictionaries for a reason. You think about a dictionary, you open a dictionary up, you look for an individual word, and associated with that word is a definition. So if you use a printed dictionary or use an online dictionary, it doesn't really matter. All right, so let's go ahead and get started. Okay, so sets and dictionaries in Python are a fairly unique structure that allows Python to store data in a little different way. So we're going to talk about some of these data collections, which are sets and dictionaries, tell us some examples of how to work with them, how to create a set, how to create a dictionary, and what you want to use them for. So whenever we have multiple elements stored together, those are called a sequence. And we might say R equals range from 1 to 10. What is R index 3? You're going to get 4. Or S equals boiler, the string. What is S index 3? Well, it's the lowercase l, right? 0, 1, 2, 3. Or L equals this list of 1, 2, 3, 4. What's at index 3? 0, 1, 2, 3. It's the number 4, isn't it? That's at index 3. So a range is an index generator, an integer generator, excuse me. We generally use those for indexes. We use it for a lot of things, just a number you want to print or work with. Strings are characters stored in order, and a list has elements that are stored in order, but notice each of these are ordered sequences. They're ordered. When you store the data in that particular order, it always comes out in that particular order. You don't store something in index 3 in a list and later on it just randomly is at index 10. You know it's at index 3 every single time, and we can access their values using indexing. But what if I have a sequence or some data structure that's not indexable? They're not stored in order. They're not ordered at all. They're like a shoebox. Just stuff is in there. Sequences are very flexible and usable in so many ways, and we've worked with them. We've talked about them, slicing, looping, even checking for membership. And here's something that's useful. If you have a list and it's got a bunch of values, look at my list. My list has 5, 8, 2, 4, 1, 5. You can use a conditional statement like if 4 in my list. Is 4 in my list? There it is. So 4 in my list is now a Boolean comparison that's true, isn't it? So I can use something like in also as a Boolean comparison to check to see if something is within a sequence. That's so helpful, right? And it has some special sequence types. We have tuples, which are ordered but immutable. You can't change them, but we could use them for indexes. And we have a set. Now a set is an unordered sequence. You actually have no idea what order those values are in that sequence, and it doesn't matter because that's not what they're used for. They're used to create unique non-duplicated values in a sequence. So it's called a set, unordered, and will not allow duplicate values. It doesn't crash if you have a duplicate value, it just doesn't save it. It only keeps one copy of every value. Then you've got a dictionary, which is unordered values that are accessed by a key value pair. Again, think about looking something up in a printed dictionary that you would look up the definition of words. So you find the words that are sorted in order. When you find the word you're looking for, there's an associated definition. That's the key, the word, and the value, the definition. That's the structure, the example of the structure you use for a dictionary. So let's talk about how we work with those. Most sequences cannot be changed if they're immutable, and unordered sequences are not accessible using indexing. Normally, something is either immutable and ordered or mutable and unordered. Sometimes, like in a set, it is both unordered and immutable, both. It's really weird. It's something that's useful to play with, and we'll talk about how they work. So this slide just gives some quick little descriptions about lists, strings, dictionaries, sets, and tuples. These are some of the data structures in Python, but these are the primary 5 that we've talked about. Now you'll notice integer and float aren't there. Boolean's not there. Why not? because that's not a data collection. That's just one piece of data, right? For an integer, you can't store 5 and 7. It's one or the other. It just holds one piece of data. But these data types are actually collections of data, and they have their own rules, their own purpose, and their own functionality. So that's what we want to talk about today. Very specifically, we want to talk about dictionaries and sets. All right, so a set is a unique data type because, number one, it uses the curly braces or the term set in its definition. So if I said x equals curly braces 2, 3, 4, this is a set with these values in it. If I said x equals this curly braces 2, 3, 4, 3, it's only going to store 3 once because the set won't store duplicate values. One way to create an empty set is x equals set with empty braces in the middle. That basically gives it an empty set. We can use a set also to eliminate duplicate values in another sequence. Let's say you have a list, and that list has student names from a class, but you know the student names are in there more than once, or a lot of them are in there 2 times, 5 times, 100 times. What if you just wanted a nice clean set of student names from a class with no duplicates? Well, if they were stored in a list, if you converted that list to a set, you would then have a clean copy of all the data that was in the list with no duplicate values whatsoever. Do you know what order they're in? No. Does it matter? No. It doesn't matter because you have this nice, clean, unique set of data with no duplicate values. Now, dictionaries are unordered, and the data is accessed using keys. So here I've got a dictionary called capital X. My first key value is AA, and its value, my first key is AA, its value is 1. My second key is 23, and its value is BB. So this dictionary definition also uses curly braces. How is that different than a set? Well, when I look at a set and the way I've defined it, it's just a sequence of values in curly braces. A dictionary has these colons between each. So that means that this right here, all of it, the key and the value, go together, then a comma, then a new key and value. And that's how Python knows the difference between a dictionary definition and a set definition. We can also do a dictionary with tuples. If you want to create a dictionary based on a list of tuples, you can just do it like this. It'll convert it directly to a dictionary for you. Inside a list, you have tuples separated by commas, and you can just convert that straight to a dictionary, and it'll work. If I want to retrieve a particular value, I use the name of the dictionary, and then in square brackets, the key. Remember here, I said key value AA. Key AA has a value of 1 associated with it. And this is a dictionary called X. So X, key value A, would give me back 1. Or I could assign it a new value. I don't want it to be 1 anymore. I want it to be 10. Or I just want to add 1 to whatever's there. Whatever, you can refer to them with the name of the dictionary and in square brackets, the key that is the reference point for the value data. So here I've got my dictionary equals the sky is going to have blue for its data. The grass is going to have green for its data. I've defined a dictionary. The colons tell me it's a dictionary. The commas separate the key value pairs, and it's all assigned as a dictionary. Maybe I've got quiz scores equals for this user or our George's. Their quiz scores is this whole tuple of data, 10, 10, and 10. And for Jay Anderson, their quiz scores are 10, 8, and 10. This tuple goes along with this student. Or maybe I've got 3 circles, a red circle, a blue circle, and a green circle. The red circle is a circle object with 2 values associated, 5 and -3. The blue value is a different circle. So think about defining a circle, and instead of adding it to a list, we've added it to a dictionary and maybe some other numbers to go along with it. This gives a dictionary's key value pair the kind of flexibility you need to store effectively an unlimited amount of data. Unlimited. Now, it actually would be limited by the amount of memory in your computer or by the amount of storage space on your hard drive, but effectively unlimited. And a very fast way to retrieve data from a dictionary using these keys. It's very, very quick. So let's talk about an example. Let's say you've been asked to write the Python program that will take something stored in a big string, like a big paragraph of text, and divide it into a list called words. In other words, if the text was the Declaration of Independence, the U.S. Declaration of Independence, you got that text and you want to divide it up into a list so that each word is a separate string within the list. Then you're supposed to create a set called unique, which is just the unique words from that big long string. So one copy of each word, no duplicates allowed. And finally, you want to define a dictionary where the keys are the entries from the set. In other words, the individual words that were in the Declaration of Independence or whatever your big long string is. And the value is how many times that word occurs in the document. Well, you're going to find a lot of things in the Declaration of Independence, and many of them happen more than once. The English language uses terms like is, the, and repeatedly. They're going to be scattered all throughout the document. But let's just go for argument's sake. So let's say that you have an original string which was a red balloon and a blue balloon are joined into a red and blue balloon. That's the original string, let's say. So I want to separate that string from a paragraph into a list called words. How do I take this string and separate, hint, split that string into a list of words? That's the first step. Then I've got this list, right? Here's what it would look like after I split it into a list. No spaces anymore, just the words. Then I'm going to take the list and get a unique set. In other words, each of these words, but only one time. So here the word A is repeated. I don't want it a second time. So my set would have A, red balloon, and blue. I already have this R joined into, I already have A, I already have red, I already have and, I already have blue, and I already have balloon. So joined into, that's the last words in my set. So I create a dictionary where R, the word R, is in my set, and I count how many times R existed in the original string. And then blue, and then joined, and then balloon, etc. So I end up with a dictionary that has word counts, right? How many times did each word occur in the original string? So what does this look like in Python? Well, we start by defining our function, and we accept the input from the user. And the user types in a red balloon and a blue balloon are joined together into one red and blue balloon. So they type that in. The next thing is I would use the split method to divide the paragraph they gave me into a list of words, para.split. Now I have a list of words. It has duplicates in it, but I have a list of words. So I want the unique words. So unique words equals take my list and convert it to a set. I still have the list. I still have the string. I also now have a set of just the unique words from this list. The next thing is to create an empty dictionary. I'm going to call it words dictionary. And then using a for loop, and what data structure do I scan through with my for loop? The set. I'm going to look through the unique words set. And for each word in unique words, how many times does that word occur in the list called words? For each word in unique words, how many times does that occur? It's the count function in the list called words. So for each word in unique words, count how many times that word happens in words. Words is my list. And assign that to my new dictionary with the key of word. So for each word, unique words, create a dictionary entry where that word is the key, and the count for how many times that word is in my list is the value. For each word in unique words, how many times does it occur in my list of words, in my original paragraph, right? And what I'll get when I print it is exactly what I'm looking for. In fact, what I get is this dictionary. R happens once, blue happens twice, joined happens once, balloon 3 times, red 2, A 3, and 2, and into once. You go back and look at the original sentence and make sure that that's actually true. So, something fairly simple like this can do what sounds like a fairly complex task. If you take the comments out of this program, the program is 1, 2, 3, 4, 5, 6, 7 lines long. And there's a very similar version of this program in Zell, in the data collections chapter, where they do word frequency analysis. It looks very similar to this. They use a slightly different approach, but it's basically the same thing. And you're going to be doing things like this in assignments coming up this semester. All right, take the quiz that goes along with this video lecture, and then move on and do homework this week. And of course, the programming exercise 3-1. Post your questions on Piazza. Have a great day.